code. So the day one puzzle of 2021 is called Sonar Sweep. The task itself is quite a long story, but the important part of this is that you are given an input of sonar readings, which looks like this. And then from that input, you'll need to check that how many measurements are larger than the previous measurements. And we even have an example. So from this input, starting with 199, we'll calculate for each row, we'll need to calculate if it's increased or decreased from the previous value. And in this example, there are 7 measurements that are larger than the previous measurements. So 1, 2, 3, 4, 5, 6, 7. Right, so let's do some calculations. The puzzle input is a couple of thousand lines long, so I'll just go ahead and copy that and paste it into the TypeScript playground. And I think it's kind of not cheating, or I think it would be cheating to handle this as integers to begin with, because it's in a string format in the assignment. So I think I'll just have this as a template string to preserve the string formatting of the assignment. So I could do something like have a value variable and then operate on that, but I think I want to have the actual code at the top. So I'm going to do this trick to get that working, because I'm going to use something like calculate. I think my keyboard is a bit wonky nowadays. And then have a function calculate that takes an input as a string format. And then let's just console log this out to get the result. So the input is 2000 lines long. That shouldn't be a problem for a decent modern computer, even running JavaScript. So I think this is quite simple task for us. So first we'll need to split the input based on the rows, right? So let's say that we want to have the values. So we'll do input.split, and we'll split by a new row, or sorry, new line to get the rows, and then we'll map the values to integers. And the correct way of doing that would be to use parseInt for it. But I think a shorthand that the TypeScript also kind of acknowledges is to use the plus sign in front of it. So it infers, it thinks that you can only use plus if you have a numeric value. So it will convert the value to a numeric value, which is what we want for now. So returning the values should give us the full list of the 2000 different numbers. So let's get the first, say, 10 values just to make sure. Okay, sounds about right. Then we'll need to loop through the values, right? And as you saw in the example, you don't consider the first value because the first value doesn't have a previous value, so you'll just consider the values that come after the first value. So I think it's just a simple for loop for now. So let's say that something like index is, it starts from 1. So this would be the 0th index, and this would be the first index. And then we'll just do that as long as the index is smaller than values dot length, then we'll increment I, and then we'll have some kind of accumulator, or let's just say it's a variable number of increased values. And it starts with 0. Sorry, index plus plus. Yeah. So if we have, we'll just need to consider the increased values, right? So if we have the current value, so let's do current value, which is the values index, right? And now we know that we can get the previous value by doing index minus 1, and this always hits something because we have the index starting from 1, and we know that, and we can kind of assume, as we are controlling the input data now, that all the lines always have previous values, and there's no kind of empties or undefineds or nans in between. So then it's just the matter of number of increased values will be plus 1 if the current value is bigger than previous value. Right. And this should work. And then we'll just return the number of increased values. So 1,195 increased values. Let's see if that was the correct answer. Yay! And we got 1 gold star. I think I could refactor this just a bit now, as I can kind of see an emergent solution for this. So let's try to do this without any intermediate values, so just with a reduce function. I think we could do this by switching the number of increased values here, right? And it starts with the value 0. And then the current value would be here. And the index would be the second one, and then we have the values here. But as we have the values in the, oh, we don't. Oh yeah, sorry. So because it's not initialized yet. So values would come from here. So I think I can do it with this. So if the current, I'll just need to kind of consider the current value, or sorry, the current index first. So if the current index is 0, then we'll need to return 0, right? Because that's always the first item. But then if we don't, then we return if the current, if the current value is bigger than values increased, current index minus 1. And this would be a true or false. So in the case it's true, we'll return 1 more, and then 0 if it isn't. And then we would have, okay, there's one error with this. Let's delete all of that for now, because now it's not using, let me see. So now we would not be using the number of increased values anywhere. So actually, we'll need to do it so that the current index, if it's 0, then we'll return number of increased values. Otherwise, we'll return either, oh yeah, let's do it like that. And then just plus so number of increased values plus current index being 0 will return 0, or then we'll return the current value. If it's bigger than the previous one, we'll return number of increased values plus 1, otherwise 0. And I think this kind of demonstrates one kind of well, let's see if it runs first. Sorry. Reduce number of increased values, current value, current index values. If the current value is bigger than values current index -1, then I think this needs a parenthesis for it to work. Let's see. Oh yeah, then we get the correct answer. But yeah, even though this is kind of in a more, so to say, more functional form, and even though const calculate is, yeah, like that. So even though this is kind of in a more simple, like it's in a more Lispy form, I think it's still much harder to read than just a regular old for loop. So let's go back just a little bit and see how the for loop solution looked like. So we had something like this versus this. Let's say that's calculate too. So which one is easier to read? I would say that just the plain old for loop is like you immediately know what's going on in here. Thus, I think it's better because it's essentially doing the same thing, but you don't need to know what these kind of extra tenaries are, and you don't need to worry about all these clever tricks that I did here. You'll just read it line by line, and you can kind of evaluate the code as you go. All right, so that's it for today. Thanks for watching and happy coding.